Welcome once again, FrazierNation.com. Today we talk about 4.7. We're going to use isosceles and equilateral triangles. We learned in 4.1 from the chart that isosceles and equilateral triangles have special properties. Students will be able to use isosceles and equilateral triangles. A few of the remembers. Isosceles triangles have two congruent sides. We learned that from 4.1. So anytime you have a triangle with two congruent sides, it's isosceles. If it's an equilateral triangle, equi means equal, so all three sides have to be congruent, the same length. Equiangular triangles, equi again means equal. If all three angles are congruent, then they are going to make an equilateral triangle. And obviously, if you have 180 degrees inside of each triangle and they're all the same, they have to be 60 degrees apiece. In geometry, if the exercise or the problem gives you information, put that information inside the picture. So I just wanted you to know that we're going to be using that later on. The next thing I want to do or tell you about, don't just use the numbering system in the book, okay? Use the title and the theorem to postulate if it has one. So, for example, like, I know a lot of students will put postulate 21. I don't want you to say that, okay? Postulate 21 has a title. Different books use different numbers, so postulate 21 in this book could be postulate 23 in the next book. Give me the title. Give me ASA, which is angle side angle. I don't want the number. I want the actual title. And then perimeter means the distance around a figure. So if I had a triangle like this and this was like 10, 7, and 5, then our perimeter, let's see, peri equals 22. Okay? Let's go ahead and move on. Vocabulary, legs. When every time you have an isosceles triangle, and let's go ahead and actually picture this thing out. Here's an isosceles triangle, and I'm telling you right now that these sides are going to be congruent. So legs, the congruent sides, and that should say congruent sides. I do apologize for my blunder, if you will. The two congruent sides in the isosceles triangle are its legs. So let me go ahead and mark this triangle. Leg and leg, okay? The vertex angle is the angle in between the legs of an isosceles triangle. So right here, this is going to be your vertex angle, okay? So here's a leg, here's a leg. This has to be the vertex angle, okay? I'm going to get this 2 bands. Get that 2 bands. 1 band, 2 band. Okay, the base. This is the third or non-congruent side of an isosceles triangle. So let's go ahead and say that this is the base. And then the base angles are going to be right here. So this is the base angle, and right here is going to be a base angle. Okay, moving on. Theorem 4.7. I don't want 4.7. I want the title. The base angles theorem. If two sides of a triangle are congruent, then the angles opposite them are congruent as well. So if AB, side AB, is congruent to side CA, then, now it might help some students to go ahead and draw arrows so that you know which arrows you're talking about. Angle B is congruent to angle C. Okay? In the converse or the backwards, let's say backwards, because remember, converse means backwards. The converse of the base angles theorem says if the two angles are congruent, then the sides opposite are congruent. So if angle Y is congruent to angle Z, then, okay, so here's that side, and here's that side. XY, side XY, has to be congruent to side XZ, okay? So if the sides are congruent, then the base angles are congruent. If the base angles are congruent, then the sides are congruent. Moving on. Corollary. So this is stuff that you just need to know. In any triangle, if it's equilateral, it has to be equiangular. If it's equiangular, it has to be equilateral. So if you know one, then you know the other. Okay? If it's equiangular, then you know all three sides have to also be congruent. If it's equilateral, then you know that all three angles have to be congruent as well. Okay? Moving on. Okay. So looking at our examples, if HK and HJ are congruent, okay, so it's not in my picture, I'm going to put it in my picture. Okay? So if that has one dash and this has one dash, then angles, so here's that angle, and here's that angle. So I know that angle HKJ has to be congruent to HJK, okay? And for angle 2, for problem 2, if angle HKJ, so here's that angle, is congruent to HJK, here's that angle, then we know that the sides opposite have to be congruent. So HK, side HK, has to be congruent to side HJ. Okay? And then find ST according to the diagram. Well, if you look at this triangle, we know that it's equiangular. Okay? All three angles have one band, so it's equiangular. Well, according to the corollary, we know that equiangular must mean that it's equilateral as well. Okay? So if this, then this. And we know that if this is equilateral, this has to be congruent to this side, to this side, to this side. So if this side is 5, this has to be 5, which means ST, the measurement of ST has to be 5. Okay? Moving on. Find the values of X and Y. Now, when you look at this problem, okay, the first thing that should jump out at you is this red box. So we know that these two angles right here mean 90 degrees, okay? And we have an equilateral triangle. So let me write that out right here. We have an equilateral triangle. So if it's equilateral, then it has to be equiangular. Okay, and we know that from our corollary. So equilateral, equiangular. So we know that this, let's go ahead and color code. If this is 60, okay, this has to be 60, which means that X is going to also be 60. So let's say the measurement of angle X is equal to 60 degrees. Okay? Now, this is the equilateral triangle. Right here, this is an isosceles triangle because only two of my sides are congruent to each other. So if isosceles, then we know that the angles across have to be congruent. Now, since this is a 90-degree triangle, 90-degree angle, then we know that this is 60, so that means that this little bitty angle right here has to be 30 degrees. When an isosceles triangle, across from our congruent sides have to be congruent angles. So our base angles have to be congruent. So if that side is 30 degrees, this side over here has to be 30 degrees. Okay? And one thing we know about every triangle in the world has to be 180 degrees. So if I have 180 minus 30 minus 30, then we know that the measurement of angle Y has to be equal to 120 degrees. Okay? So here's angle X, and here's angle Y. Okay, number 5, find X. Well, what type of triangle do we have? Well, we have two angles that are congruent, so we know that each side that is across from them have to be congruent. So we know that this is an isosceles triangle. So we know isosceles triangle, let's write that down. So if we have an isosceles triangle, we know that 2x minus 1 is equal to x plus 4. Okay? And use your algebra 1 skills, subtract x on both sides. And so I have x minus 1 equals 4. And so I have x equals 5. Okay? And yeah, there it is. X equals 5. We're going to need that type of work to do the next problem. So moving on. Find X. So I have an isosceles triangle here, so I don't know. I just keep wanting to point out isosceles and equilateral triangles. So here's an isosceles triangle, and we know that the vertex angle has to be 40 degrees, okay? And we're trying to find X. So if this is 40 degrees and every triangle has 180 degrees, then we know that between these two angles has to be 140. Okay, so it's going to be 180 minus 40, so that's 140 degrees. Okay, we know that angle B and angle C have to be congruent because these are base angles. Okay, so angle B and angle C are base angles, and we know that base angles have to be congruent. Okay, we know that they're congruent. So we know that 140 divided by 2 is equal to 70 degrees. Okay, so this has to be 70 degrees. This has to be 70 degrees. Oh, well, what do you know? I see here that 70 degrees is equal to 2x minus 2. So 70 equals 2x minus 2. Add 2 to both sides. Cross that out. 72 equals 2x. So I know, and I always want my x on the left. X is equal to 36 degrees. Okay? And then find the perimeter. At the very beginning, I told you perimeters when you add everything else up. So first and foremost, we want to solve for x. Okay? Let's go ahead and mark this off. So solve for x. So since this is an isosceles triangle, okay. Whoa, sorry about that. Being that this is an isosceles triangle, we know that these two have to be congruent to each other. So I have here 2x minus 5 is equal to x plus 3. Okay? So I know if I subtract x, I have x minus 5 equals 3. So I know that x has to be equal to 8. Okay? So if x is 8 and I plug back in, well, I know that this side over here must be 11. Okay? Well, my isosceles triangle, I don't even have to pull that. I don't even have to plug that in. I know that this side has to be 11 too. So the perimeter is going to be 11 plus 6. So that's 22 plus 6. So we know that the whole thing has to be 28. Okay? Well, ask me questions. I'm going to put 4.7 homework up soon. Okay? Test is going to be very soon. Okay? I would get on that young Quizlet if I was you. You know, flashcards are always the way to go. And finally, I just might have a little bit of extra credit. Okay? So anyway, get at me. I'll holler. See ya.